Hello everybody, welcome back to Teach Me to Science, and today we're going to be talking about rates. So first we're going to define rates and then we're going to write some rate expressions. A rate is defined as a change in concentration over a change in time. So these little brackets that I've drawn are shown to designate a concentration of one particular species, and the T is a designation of time. It's important to know that the triangle here, or the delta symbol, stands for a change, which also can be described as a final concentration or a final time minus an initial concentration or initial time. Basically, a delta means final minus initial. One way chemists use rates is to describe the overall rate for a reaction. So a rate expression for a reaction relates every single component of the reaction to one another. So the basic method for writing a rate expression is to do 1 over the coefficient in front of your particular species times the change in concentration of that species over the change in time. You do that for every single component of the reaction. So here I've drawn both of the reactants of this reaction that I have, and now I'm drawing the rate expressions for each individual component of the products. It's important to note that the signs for the reactants are always negative. This is because the reactants are being used up to create the products. So the amount of reactants is decreasing as the amount of products increases. It's also important to note that everything is equivalent to each other. This is because the reactants are being used up at the same rate as the products are being formed. Now let's practice writing a rate expression for an actual reaction. Pause the video and give it a try. Alright, like I said before, the formula for doing this is 1 over the coefficient times the change in concentration over the change in time. So here I've got a negative change in CH4 concentration over change in time. It's negative because it's a reactant and the coefficient in front is 1. Now I have 1 over 2 because the coefficient in front of oxygen is 2. There should be a delta symbol in front of that concentration of oxygen because it's change in concentration over change in time. Now I've got the change in the concentration of CO2 over the change in time, and again the coefficient is 1, and it's positive this time because it's a product. Finally, 1 over 2 because 2 is the coefficient in front of water, and I've got the change in concentration of water over change in time. Alright, that's all for this video about rates. I hope you enjoyed this video. If you could, please like and subscribe to my channel. I would greatly appreciate it. Bye!